Hi guys, this is the EdExcel A-Level Maths Paper 2 from the June 2019 papers. Let's get straight into it. Okay, so now in terms of the examiner report, let's read what's been said. This is the first time in many years that a full A-Level Maths cohort has had linear papers. Some candidates, those of lower ability, struggle to access a lot of questions. You can read about those questions in this examiner's report. There were some parts of questions involving sector formulae, functions, iterations, trigonometry and differentiation where a typical E grade student could gain some marks. There were more testing questions involving indices, parametric equations, functions, mathematical modelling, geometric series, linearization, the use of differentiation to solve minimization problems, integration and differential equation that allow the paper to discriminate well between higher grades. And then you can see about the different questions which people were struggling on below here. Question number 1. Given that 2 to the power of x times by 4 to the power of y is equal to 1 over 2 times by the square root of 2, we have to express y as a function of x. So for this question, if we consider the right hand side, we can write the right hand side as a power of 2. So we have 2 to the power of x times by 4 to the power of y, that's equal to 1 over 2 to the power of 1 times by 2 to the power of 1/2. And because we have the same base numbers, we can add the powers. So we have 1 over 2 to the power of 1 plus 1/2. So we have 1 over 2 to the power of 3 over 2. That's the same as 2 to the power of minus 3 over 2. Now this 4 we can rewrite such that we have 2 to the power of something. So we have 2 to the power of x times by 2 squared to the power of y, and this of course is equal to 2 to the power of minus 3 over 2. And we have a power raised to another power, and therefore we multiply the powers. So we have 2 to the power of x times by 2 to the power of 2y. This is equal to 2 to the power of minus 3 over 2. And here we have the same base numbers. We can therefore add the powers. So we have 2 to the power of x plus 2y. This is equal to 2 to the power of minus 3 over 2. And we can find y as a function of x by comparing powers. So if we compare the powers, we have x plus 2y equals minus 3 over 2, and therefore y, that's equal to minus x over 2 minus 3 over 4. So in terms of question 1, this actually proved to be quite challenging for a lot of candidates, which is actually quite surprising. It was a very easy question in my opinion. This was probably because of the more open-ended nature of the question, allowing candidates to select their own problem solving strategy to express y as a function of x. It was not apparent to most candidates that y could be expressed as a linear function of x. More able candidates, however, were able to provide a concise solution. Other candidates were still able to achieve full marks, but expressed y as a more complicated function of x. A few candidates attempted to express x as a function of y, suggesting a lack of understanding of the terminology. Y as a function of x means y equals something. It appeared that most candidates failed to realise that this question could be solved purely using indices. Instead, most candidates chose to immediately take logarithms as their first step towards a solution. A correct first step, for example, log of 2 to the power of x times 4 to the power of y equals log of 1 over 2 root 2, was rewarded by the mark scheme. Unfortunately, some candidates combined taking logarithms with an incorrect application of the addition law for logs as their first step, therefore gaining no marks. And then you see what's been written over there. Most candidates who had a correct first step went to achieve full marks, with only some failing to do so by making an arithmetic error. Let's see what else was said. This question highlighted some candidates' weaker algebraic indices and logarithmic skills. We see common errors included over here. 2 to the power of x times 2 to the power of times by 4 to the power of y, giving 8 to the power of xy. That's incorrect, and we see other incorrect points being mentioned over here. The most common correct answers were y equals log of 1 over 2 root 2 minus log of 2 to the power of x over log of 4. And then we've got other solutions over here, and only a minority of candidates obtained a correct y equals minus a half x minus 3/4. This is just GCSE work in my opinion. There is nothing complicated in this question. You just have to know your laws of indices to do this question. Question number 2. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. The results are given in the table below with the time in seconds and the speed in meters per second. And using this information, we have to estimate the length of runway used by the jet to take off. So what I've done over here, I've just plotted these points over here on a graph. Along this axis, we have the time in seconds, and along this axis we have the speed in meters per second. And you'll notice over here we have a speed time graph, and the area under a speed time graph is the distance. Let's just write that down. So the area under a speed time graph is the distance. Now, what we have over here is various different points which are connected together. And the distance x, that's given by the integral of the velocity with respect to time. And we can use the trapezium rule to estimate this area. Of course, we have various different pieces of trapezia. So what we wish to do in this question is find out the area of the following shaded bit. So we wish to find the area of this. And of course we can use the trapezium rule. Hopefully you can see this curve is split up into various different trapezia. Okay. So for the trapezium rule, first of all, we can go to the formula book, and under the numerical methods section, we have here the trapezium rule stated. So over here we have x, which is approximately h over 2 lots of y0 plus 2 lots of y1 plus y2 plus y3 plus y4 plus y5. Now these values are over here: y0, y1, y2, y3, y4, and y5. And we can quite easily work out an approximation for the area by substituting these into this formula here. Now h, that will be the distance between each interval, so we have 5 for h. So we have 5 over 2 lots of 2 plus 2 lots of 5 plus 10 plus 18 plus 28 plus 42. And if we work this out, we get 415 meters. And now for part B, given that the jet accelerated smoothly in these 25 seconds, we have to explain whether our answer in part A is an underestimate or an overestimate of the length of the runway used by the jet to take off. Well, if it accelerated smoothly, we won't join the points together with straight lines. Instead, we'd have a smooth curve. And perhaps if we join this point to this point, hopefully you can see whether we have an underestimate or an overestimate. So over here, we can see that we have an overestimate because the trapezia are above the curve. And that's what I've put over here. In terms of question 2, this actually proved to be quite challenging, with a significant number of candidates struggling to realise that the length of the runway could be estimated by the area under a speed time graph. And it's just a general point which you should know from your mechanics studies. And we've already been given a table. Part A, only a minority seem to realise that you can apply the trapezium rule, and those who did got a correct answer of 415. While the table of values clearly shows an interval width of h equals 5, the application of the formula h equals b minus a over n, with n equaling 6 instead of n equaling 5, led to some candidates to use an incorrect strip width of 25 over 6. I always say that h is the distance between each entry in the table, so the difference between each of these is 5. What else do we see over here? Some candidates used the equation of motion with constant acceleration to estimate the length. Many of the candidates who used this method applied the calculation 2 plus 42 over 2 times by 25 to obtain an estimate of 550. A few used v equals u plus at, and then they used s equals u t plus a half at squared to estimate the length. Some candidates used u equals 0 in their SUVAT calculations. Remember, at time t equals 0, the initial speed is 2 meters per second. You see that in that table below. But it's not a mechanics paper, it's just an A-level pure maths paper, so you can use the trapezium rule. What else can be said? A few candidates used a method which was equivalent to the trapezium rule of applying SUVAT to each of the 5 time intervals, giving a correct answer of 415. In terms of what else was said in this question, there were other methods. People summed up the rectangles which enclosed the area above the curve for each of the 5 time intervals, summing up the areas of rectangles which enclose the area below each of the 5 intervals, and applying the average speed times by total time. The most common methods which were deemed incorrect, those are shown below over there, where they had that looks like working out the sum of the speed times by the times. For part B, that was talking about whether you have an overestimate or an underestimate. There were those who, while many candidates who used a trapezium rule over a SUVAT method, these identified their length to be an overestimate. Some had difficulty articulating a reason for this. Those who were more successful drew a diagram which showed clearly the extra area generated by the trapezium rule in relation to the curve. Some candidates sketched that the speed time curve and explain that only that the curve was convex, or that the acceleration continually increasing. Only a few candidates who used a rectangle method were able to give a correct reason. Some candidates answered Part B by finding alternative estimates and comparing it with their answer in Part A. There were others who included that they found the 415 in Part A and 550 in Part B, and then concluded that they had an underestimate. Other candidates who also received no credit gave physical explanations about friction, air resistance, or the shape of the aircraft, while others stated the jet accelerated smoothly. Not a very difficult question, but made more difficult than what it needed to be. It's only worth 1 mark as well, so don't put in more work than. Question number 3. Figure 1 shows a sector AOB of a circle with centre O, radius 5 cm and angle AOB 40 degrees. The attempt of a student to find the area of the sector is shown below. Area of a sector, that's 1/2 r squared theta, so we have 1/2 times 5 squared times by 40, which is 500. We have to explain for Part A the error made by the student. They've used 40 degrees. When using this formula, we must ensure theta is in radians. So for Part A, theta should be in radians. Okay, now for Part B, we have to write out a correct solution. Well, indeed, we still use this formula, but we would have to convert the 40 degrees into radians. So the area that's given by 1/2 times by 5 squared times by 40 degrees in radians. So we have 40 pi over 180. And therefore the area that will be given by 25 pi over 9 centimeters squared. Now question 3, that was the most accessible question in the paper. A lot of people gained full marks, which is good. Part A, where we had to explain the error, most could explain that the angle 40 degrees should be in radians for it to be applied to that formula, 1/2 r squared theta. Some candidates' explanations lacked sufficient detail. For example, they said this the angle is in degrees, but failed to mention that the angle used in the formula should be in radians. A few candidates did not give a reason in Part A, but correctly calculated the area of the sector AOB in Part B, which was well answered. Those who answered Part B correctly converted the 40 degrees to radians. In radians it's 2 pi over 9, and then applied the formula. Some candidates applied the correct formula, pi r squared lots of theta over 360, with theta equaling 40. Errors included converting the 40 degrees to either 40 pi over 360 or non pi over 2, and then they subbed it into the formula and got an incorrect answer. Most candidates gave their units, which is centimeters squared, to Part B. A lack of units in this question was condoned. Question number 4. The curve C1 with parametric equations x equals 10 cos t, y equals 4 root 2 sin t, where t is in between 0 and 2 pi, meets the circle with C2 with equation x squared plus y squared equals 66 at 4 distinct points as shown in figure 2. And given that one of these points S lies in the 4th quadrant, we have to find the Cartesian coordinates of S. Okay, so if we're considering the 4th quadrant, we're considering a positive x but a negative y. So if we substitute these parametric equations into this Cartesian equation and solve simultaneously, we have x squared, so we have 10 times by the cosine of t squared plus y squared, so we have 4 root 2 times by the sine of t squared, and this is equal to 66. So we have 100 cos squared t plus 32 sine squared t equals 66. And we should know one of the standard identities. Sine squared theta plus cos squared theta equals 1, and therefore from here sine squared theta is equal to 1 minus cos squared theta. And therefore, replacing the sine squared t with 1 minus cos squared t, we would have 100 cos squared t plus 32 lots of 1 minus cos squared t equals 66. And if we expand and simplify, you'd see we have 100 cos squared t plus 32 minus 32 cos squared t equals 66. And therefore, simplifying this further, 68 cos squared t, that's equal to 34 cos t, that's equal to plus minus 34 divided by 68, that's 1/2. So cos t is equal to plus minus the square root of 1/2. Okay? So from this we can find out what t is. So therefore t, that's equal to pi over 4 and 7 pi over 4. Okay? I think at this point actually drawing the graph of sine and cosine will actually help. So having drawn the graphs, if we consider this diagram again, we want the y coordinate to be negative. And for that, we must take the obtuse angle. So therefore, you can see that t is equal to 7 pi over 4. The reason being we want the obtuse, because we want y to be negative. So substituting into x and y, we see that x is equal to 10 times by the cosine of t, so we have 10 times by the cosine of 7 pi over 4, which is 5 root 2, and we see that y, that's equal to 4 root 2 times by the sine of 7 pi over 4, and if you work that out, we get minus 4. And therefore, the coordinates of s, that's given by 5 root 2 minus 4. Question number 4. This was well attempted by both medium ability and higher ability candidates. Lower ability candidates struggle to make progress, with most of them scoring no more than 1 mark. There were 2 common methods that were used by candidates. The first method, covered by way 1 in the mark scheme, was the substitution of the parametric equation of C1 into the Cartesian equation of C2 to give an equation in T only, and that's what we did. And then the trigonometric identity sine squared plus cos squared equals 1 was used to obtain an equation in sine squared or cos squared only, and a value of application of the trigonometric identity and then the value of sine theta or cos theta was found. The second method was the application of the identity shown to the parametric equation of C1, and that gave x over 10 all squared plus y over 4 root 2 all squared, the Cartesian equation of C2 being used to obtain an equation in x squared or y squared only, and then you found out x and y. There were other methods too, but at some point you were supposed to realise, because we're talking about the fourth quadrant, x must be greater than 0, but y must be less than 0. Some candidates incorrectly stated s as 5 root 2 4. In the first method, successful candidates either used t equals 7 pi over 4 or t equals pi over 4 and then applied symmetry to find the coordinate of s. An area of concern centered around arithmetical slips or errors in elementary algebra. Examples of the former include 4 root 2 all squared becoming 8 or 64, and sine squared t equals 1/2 becomes sine t equals 1/4, and then the errors followed on from that. Question number 5. We have figure 3 over here, which shows a sketch of the curve with the equation y equals root x, and the point P with coordinates x, y lies on the curve. The rectangle shown shaded in figure 3 has height y and width delta x. We have to calculate the limit as delta x tends towards 0 of the sum of root x delta x between x equals 4 and x equals 9. And all we're saying over here is we need to evaluate the integral of root x with respect to x between x equals 4 and x equals 9. The reason for that is we can split this into an infinite number of rectangles, and when we split that up into an infinite number of rectangles, we will be integrating. So let's show that on this diagram. So the idea is over here we have an infinite number of these rectangles, and when we add up all these rectangles together, essentially we're taking the integral. So what this is equal to is the integral from 4 to 9 of square root of x with respect to x. So square root of x, that's the same as x to the power of a half. So we're integrating x to the power of a half with respect to x. And if we work this out, add 1 to the power, we get x to the power of 3 over 2, divide by the new power. It turns out our integral is 2x to the 3 over 2 over 3. And we wish to evaluate this in between. We wish to evaluate this between 4 and 9. And if we work all this out, for our upper limit, we have two lots of 9 to the power of 3 over 2 over 3 minus 2 lots of 4 to the power of 3 over 2 over 3. And it turns out if we tidy all this up, we get 38 over 3. So that is the result of this. Question number 5, this was actually quite challenging for a lot of candidates because they were unfamiliar with the notation, and there were a lot of blank responses as a result of this. In this specification, we were supposed to recognize that the sum from x equals a, or that the integral of f of x with respect to x from a to b is the same as the limit as delta x tends towards 0 of the sum of x equals a to x equals b of f of x delta x. There weren't similar questions to this before, that's why a lot of people struggled. But those who recognised that this was just another way of writing the integration, they correctly found all the marks. Only a few made errors in integrating x to the half, which is the same as square root of x, or in the application of the limits. some applied the trapezium rule but did not link the trapezium rule with the stated integral. Other candidates attempted to sum root x using integers from x equals 4 to x equals 9. I don't know why you do that. Some candidates mistakenly interpreted delta x as a trigger to differentiate root x, with a few candidates attempted to differentiate root x from first principles. But yeah, I thought overall it was actually quite easy. Question number 6. Figure 4 shows a sketch of the graph of y equals g of x, where g of x is a piecewise function. We have x minus 2 all squared plus 1, where x is less than or equal to 2, and 4x minus 7, where x is greater than 2. And we have to find the value of g of 0. So I suggest you work out the inner bit and then work out the outer bit. First of all, working out g of 0 for part A. G of 0, well 0, that is less than or equal to 2. So we use the function here, x minus 2 all squared plus 1. So we have 0 minus 2 all squared plus 1, which is 5. So now we need to work out g of 5. So g of 0, that's the same as g of 5. And if we work out what g of 5 is greater than 2, so we use the 4x minus 7 bit. So we have 4 lots of 5 minus 7, which is 13. Now for part B, we have to find all values of x for which g of x is greater than 28. So first of all, the 28, that is somewhere over here. We'll draw it in green. So this is the line y equals 28, and we've got our piecewise function. We've got two separate bits to it. We've got this bit over here, 2x, we've got the bit over here, x minus 2 all squared plus 1. So let's just label that. We've got x minus 2 all squared plus 1, and for the other bit we've got 4x minus 7. And this critical region here, this critical region, that's 2. And we're looking at where the graph is greater than 28. So we're looking at essentially this bit here and this bit over here. And for that, we'd have to find the intersection points. So we'd have to find this bit and this bit. And for us to do that, we can solve x minus 2 all squared plus 1 with y equals 28, and we can also solve 4x minus 7 with y equals 28. So let's do that. For part B, we begin with the x minus 2 all squared plus 1 equals 28. X minus 2 all squared, that's equal to 27. X minus 2, that's equal to plus minus 3 root 3. And therefore, x, that will equal 2 minus 3 root 3. And hopefully you can see why we take the negative from the diagram. So this point over here, this is 2 minus 3 root 3. And now for the other bit, we have 4x minus 7 equals 28. 4x, that's equal to 35. And therefore, x, that's equal to 35 over 4. So we have 35 over 4 over here. And therefore we can read off the inequality. Hopefully you can see that x is less than 2 minus 3 root 3, or x is greater than 35 over 4. So therefore our solutions, we have x is less than 2 minus 3 root 3, and we also have x being greater than 35/4. For part C, the function h is defined by h of x equals x minus 2 all squared plus 1, where x is less than or equal to 2, and we have to explain why h has an inverse but g does not. And we have the following explanation. So h of x is 1 to 1, but g of x is many to 1, and therefore h of x has an inverse but g of x does not have an inverse. And now for part D of the question, we have to solve the equation the inverse of h equals minus a half. Now for this, of course, we know what h of x is. We need to now find the inverse of that. So we have, if we write these steps down in a different colour, we begin with h of x, which is equal to x minus 2 all squared plus 1, and remember we are restricted with this domain x is less than or equal to minus 2. So if we replace the h with y, we have y equals x minus 2 all squared plus 1. Replace the x and y, swap them round. We have x equals y minus 2 all squared plus 1. Rearrange for y, that's equal to 2 minus the square root of x minus 1. And the reason we take the minus is because x is less than or equal to minus 2. And therefore, if we replace the y with the inverse of h, that's equal to 2 minus the square root of x minus 1. So we're solving this equation equal to minus 1/2. So we have 2 minus the square root of x minus 1, that's equal to minus 1/2. So we have x minus 1 square rooted, that's equal to 5/2. X minus 1, that's equal to 25/4, and therefore x, that's equal to 29/4. Question 6, examiner report-wise discriminated well between candidates of all abilities, with only a few candidates gaining full marks. There were some marks in Part B and Part D which were accessible to the majority of students. Now in Part A, where we had to find the value of g of 0, many candidates struggled to split the domain for g of x, as shown here, and only a minority gained both marks. Many candidates found a correct g of 0 equaling 5, but a significant number used the incorrect method of substituting 5 to give g of 0 equaling 5 minus 2 all squared plus 1, which is 10. Only a minority used a correct method and found g of 0 equaling 4 lots of 5 minus 3 equals 13. Occasionally, candidates found an algebraic expression for g of x, although this was often incorrect. Very few obtained a correct answer of 13 by substituting x equals 0 into this over here. Part B, where we had to find all values of x for which g of x is greater than 28. Many attempted to solve that inequality by finding the critical values of x, which I did in the question. Most solved the linear equation to find a correct critical value of 35/4, and many solved the quadratic to find x equaling 2 plus minus 3 root 3. A minority rejected x equals 2 minus 3 root 3 and deduced that x equals 2 minus 3 root 3 was the setting critical value. I think they were supposed to say plus over here. Only a few candidates used the critical values and the diagram shown here to find the to write down a correct solution, shown here. Some candidates, however, incorrectly gave x equaling 35 over 4 and x equaling 2 plus minus 3 root 3 and gave these solutions here as a final answer. A few candidates made no credible progress in part B by using a method of equating both parts of g of x and attempting to solve the equation shown here. Part C, we had to explain why h has an inverse but g does not. A few candidates only wrote a comment about one of the two functions. A significant number of candidates believe that g did not have an inverse due to it being defined in two parts. However, candidates who were successful in part C usually gave a reason such as g is many to 1 and h is 1 to 1. A few correctly stated that the inverse of g is 1 many, which is not a function, whereas the inverse of h is 1 1, which is a function. A few candidates incorrectly described g as a 1 many function. Part D, where we had to solve the inverse of h equaling minus a half. Only a few candidates applied the method of finding x by applying h of minus a half. As this method was less prone to error, most candidates who used it scored full marks. Most candidates applied a complete method of finding their inverse of h, followed by using their inverse to form and solve this equation, and that's what I did. This was because they used the incorrect h shown here. Sorry, some gave this answer of x equaling 7.25 and lost the mark because they gave their inverse as 2 plus root x minus 1 instead of 2 minus root x plus 1. A few candidates in part D incorrectly believe that the inverse of h referred to the reciprocal of h or even the first derivative of h with respect to x, which is also incorrect. Okay, so now for question number 7. A small factory makes bars of soap. On any day, the total cost to the factory, y pounds, of making x bars of soap is modelled to be the sum of two separate elements, a fixed cost and a cost that is proportional to the number of bars of soap that are made that day. And for part A, we have to write down a general equation linking y with x for this model. Well, if we see that the cost is proportional to the number of bars of soap, that tells us we have a linear model. We have a fixed cost, and therefore for part A, the general equation for this situation, that would be y equals kx plus c, where c is this fixed cost and k is this constant of proportionality. Part B. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500, and on a day when 300 bars of soap are made, the factory makes a loss of £80. And with this, using the above information, we have to show that y equals 0.84x plus 428. Now, if you did not know what to do for part A, if you look further on in the question, this suggests to us that we had to write down a linear equation linking y with x. So, first thing we need to recognise, 800 bars of soap, profit is £500, and therefore we know that each bar of soap is sold for £2. So what we have over here then, first of all, is 800 bars of soap at £2. Well, each bar is £2, so we have 800 bars at £2 each. So therefore, the cost over here, so the total selling cost is £1,600. Okay, so this £1,600 is the total selling cost or selling price, and therefore the cost that's equal to the selling price minus the profit. So we have 1,600 minus 500, that's equal to 1,100. So here we have £1,100. Okay, so that is the cost of making this 800 bars of soap. Okay, now if we consider this 300 bars of soap, again at £2 each. So let's make that clear, we're selling them at £2 each. That tells us over here we have £600 being the selling price. Okay, so we have £600 for the selling price, and therefore the cost over here, the cost that's equal to this selling price 600, and because we have a loss of £80 here, we would have to add on 80. Okay, and that is because we have a loss of £500, and remember we subtract off the 500 from here because we have a profit of £500. And therefore what you'd find over here, the cost to make these 300 bars of soap, that will be £680. Okay, and therefore from these two statements we can conclude we have two equations. If we substitute into our general equation for y, we have 1100 equals 800k plus c. So we have x being 800, that's how many bars of soap, and then y, that's the cost. So we have 1100 equals 800k plus c, and similarly over here we have 680k equals 300k, 680 equals 300k plus c. We'll call this equation 1, we'll call this equation 2, and therefore solving 1 and 2 simultaneously, hopefully you can see k, that's equal to 0.84, and c, that's equal to 428. And you can do this on your calculator if you don't know how to do that. And therefore what we can conclude over here, y, that's equal to 0.84 x plus 428, and this over here is the cost of soap. Okay, now for part C of the question, with reference to the model we have to interpret the significance of the value 0.84 in this equation over here. Okay, so we have the following reason. We have k equals 0.84, which is the cost of making each extra bar of soap. And now for part D, assuming that each bar of soap is sold on the day it is made, we have to find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. Okay, now let's break this question down. For part D, we know that we sell soap for £2 each. So we sell the soap for £2 each. Okay? And if we sell X bars of soap, then for us to make a profit, we have the following inequality. So we have, if x bars of soap are sold, then for profit 2x minus y is greater than 0. Let's explain this. We've got the 2x, that comes from the fact that we're selling soap for £2 each. We have the minus y, this over here, that will be the cost of the soap, that's given over here. And this being greater than 0 is the condition for profit. Hopefully that makes sense. So we have our selling price minus the cost, that must be greater than 0 for us to have a profit. And of course we know that it must be greater than 0 because the question says the least number of bars. That suggests to us that we should have some sort of an inequality. So we have 2x. So we have 2x minus 0.84 x plus 428, and this is greater than 0. So we have 1.16 x being greater than 428, and therefore x that's greater than 428 divided by 1.16, which is 368.9, etc. So we have 368.9, etc. Okay, and therefore what we can conclude is that the least number of bars of soap is 369. So therefore the least number of bars of soap is 369. Question 7. So for this question, this discriminated between the medium and higher ability candidates. A lot of people struggled to make a lot of progress in this question and scored no more than 1 mark. Part A, most were able to write a correct equation in the form y equals kx plus c, with k and c being constants. A minority struggled to give a suitable form of the linear equation, with some omitting the fixed cost constancy. Some candidates gave incorrect answers such as y being proportional to x, equations involving exponential models, or differential equations. I thought it was quite obvious that why we had a linear model. For part B, this proved to be quite challenging. We had to show that y equals 0.84 x plus 428. Let's read why this was challenging. Many struggled to grasp the concept profit equals sales minus cost. Do remember that it's quite a straightforward thing which you should know from common sense in life. Many incorrectly assuming that their model from part A was the profit made. Y is the cost. Many candidates used the 800, 500 and either the 380 or 300 minus 80 to form 2 linear equations, and then solved simultaneously to find that k to be 0.84. Those candidates who understood the link between profit and cost usually found the total cost to the factory of £1,100 and £680 for 800 and 300 bars of soap respectively. Most used 800, 1100 and 300, 680 to form 2 linear equations and then proceed to find the gradient of 0.84, a y-intercept of 428. A large proportion concluded by stating the given equation y equals 0.84x plus 428. A few candidates, however, did not complete their analysis with a suitable conclusion and so lost the final mark. Some candidates used 800, 1100 and 300, 680 to verify the model y equals 0.84x plus 428. Many of these were successful but often failed to give a suitable conclusion stating that their model was true. So I was unsure to do that at first, but I guess from reading the examiner reports that seemed totally legit, but you have to give a conclusion with it. Part C, we had to talk about what the constant k equals 0.84 meant. A lot of candidates, Part C gave a significant number of candidates their only credible access to question 7. Some candidates gave a correct interpretation, such as 0.84 represented the cost of making an extra bar of soap. Incorrect explanations included that 0.84 represented the selling price of a bar of soap or the profit per bar of soap made. Part D, we had to find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. Again, we had to use that profit idea. Let's see what's been written over here. There were mixed responses to this question. The most popular approach was to form and solve a correct 2n equals 0.84n plus 428, or the 2n being greater than 0.84n plus 428, which mostly led to the correct answer n equals 369. The final answer left as an inequality, such as n being greater than 368 or n equaling or being greater than 369, without reference to the statement that 369 was the number of bars required, was not sufficient for the final mark. Some candidates used trial and error, and from that they usually found n equaling 369. Question number 8. We have to find the value of the sum from r equals 4 to r equals infinity of 20 times by 1/2 to the power of r. Now, hopefully over here, you can see that this sum over here is the sum from r equals 1 to r equals infinity minus the sum of the first 3 terms. And I think it would help if you recognize over here f of r, that's equal to 20 times by 1/2 to the power of r. So when we come to work out this series, we have the following. We have the sum from r equals 4 to r equals infinity. That's the same as the sum from r equals 1 to r equals infinity minus the sum of the first 3 terms. And over here, hopefully you can recognize we have here a geometric series to infinity. Let's just write this down. So here we have a geometric series to infinity, and here we have a geometric sum to 3. Okay? And the reason we have this geometric sequence is because we have something to the power of something else, and we're multiplying by a constant term 1/2. So with this we can find out our first term of the geometric series, and that's when r is equal to 1. So when r is equal to 1, we have 20 times by 1/2 to the power of 1, which is 10, and therefore the first term, that's equal to 10. We see here that the common ratio that's equal to 1/2. So when we come to find out this geometric series bit to infinity, what we have over here then is the following. The geometric series from 1 to infinity of 20 times by 1/2 to the power of r. We can look in our formula book. We would have to use this formula over here. So we have over here 10, that's our first term, over 1 minus r, so we have 1 minus 1/2, and it turns out we get 20. So this 20 corresponds to the sum to infinity. Okay, and now for the first three terms, we have the following. We have the sum of the first three terms. We have the first term plus the second term plus the third term. And if we work all of this out, it turns out we get 35/2. So this bit over here corresponds to the sum of the first three terms. And therefore, we can conclude over here that the sum from r equals 4 to r equals infinity of 20 times by 1/2 to the power of r, that's equal to 20 minus 35/2. It turns out we get 5/2. Okay, so our final answer is 5/2. Now for the next part of the question, we have to show that the sum from r equals 1 to n equals 1 to n equals 48 of log base 5 of n plus 1 of log base 5 of n plus 2 over n plus 1 equals 2. Okay. So this summation, well, when n is equal to 1, we have log base 5 of 1 plus 2, which is 3, and then 1 plus 1, that's 2. So we have log base 5 of 3/2. When n is equal to 2, we have 2 plus 2, which is 4, and then 2 plus 1, that's 3. So we have log base 5 of 4/3. When n is equal to 3, we have 3 plus 2 over 3 plus 1. So we have log base 5 of 5/4. And we can continue this all the way up to n equals 48. When n is equal to 48, 48 plus 2, that's 50, 48 plus 1, that's 49. So our final term would be log base 5 of 50/49. Hopefully this is so far straightforward. So log base 5 of 3/2, that's the same as log base 5 of 3 minus log base 5 of 2. Log base 5 of 4/3, that's the same as log base 5 of 4 minus log base 5 of 3. And for this term, that's log base 5 of 5 minus log base 5 of 4. And we can continue this up to the final term, where we have log base 5 of 50 minus log base 5 of 49. And here hopefully you can see, well, this term would cancel with this term. This term will cancel with this term, and we can continue on with this. So over here I should really correct this actually. So here we have these extra terms in the middle, and hopefully you can recognize somewhere that this final term will cancel out as well. And therefore what we end up with is log base 5 of 50 minus log base 5 of 2. We can combine these together. So we have log base 5 of 50 over 2, and that turns out to be log base 5 of 25. Okay, now 25, that's the same as 5 squared. Now we have to pay attention to what we have over here. It's a show that question, so show all your steps. Log base 25, that's the same as log base 5 of 5 squared. So here we have log base 5 of 5 squared, and we can power slide this to the front. So we have 2 times by log base 5 of 5. Log base 5 of 5, that's 1. So we have 2 times by 1, which is equal to 2. And therefore, in conclusion, we can state the following. We can state that this sum from n equals 1 to n equals 48 of this thing is equal to 2. Question 8, this was actually quite a difficult question, with the first part being answered more successfully than the second part, which is actually quite surprising. In other words, those candidates that wrote the following and over here and this bit gained a better understanding of the series that they were required to sum. Anyway, there were, however, many attempts that made no credible progress and a significant number of blank responses to either one or both parts of question 8. The first part, many candidates identified the sum to infinity required this formula over here. A lot of people used r equaling 1/2 in this formula, although some used r equaling a quarter or minus a half. Disappointingly, a significant number of candidates used r equals 4 to find an expression given in the question and applied it in the formula a over 1 minus r, even though this formula only works when r is in between -1 and 1. There were a number of correct strategies that candidates could use. The most successful strategy was shown over here, with r equaling 1/2 and a equaling 20 lots of 1 over a half to the power of 4. I did it a different method. I did it the method shown over here, which was to notice that this sum is the sum as the sum from 1 to infinity minus the sum of the first 3 terms. Now for the second part, we had another series over here. There were 2 main correct methods that were used by candidates in equal measure. One was to list the first few terms and the last few terms of the series, and then use the addition law of logs to cancel out, and that's what I did over here. Other methods was to use the subtraction law of logs to give this over here, and to list the terms as shown here, and then you'll notice some terms cancel out, and then you can end up at the final answer. Some candidates incorrectly assumed that an arithmetic series was required, and they used n over 2 lots of a plus l, or n over 2 lots of 2a plus n minus 1 lots of d, with n equaling 48, a equaling log base 5 of 3 over 2, and l equaling log base 5 of 50 over 49, and d equaling log base 5 of 4 over 3 minus log base 5 of 3 over 2. A few candidates incorrectly assumed a geometric series and attempted to find its sum, and then there were some who made no credible progress by putting their answer in decimal. Question number 9. A research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log base 10 d against log base 10 of v were plotted. We see those in figure 5 and 6. And the results are shown below together with a data point from each graph. Here in figure 5 we've got the point 30, 20. Here in figure 6 we've got the point 0 minus 1.77. For part A we have to explain how figure 6 would lead the engineer to believe that the braking distance should be modelled by the formula d equals k lots of v to the power of n, where k and n are constants, and k is approximately 0.017. Well, let's first of all label these figures. Here we have I, here we have I. And this graph over here, that's a straight line. So we can compare that with y equals mx plus c. So let's do that. For part A, we will compare this second equation with y equals mx plus c. So we have log base 10 of d, that's this y-axis, so to speak. So we have log base 10 of d, and this is equal to m, that's the gradient, lots of x. Well, this is essentially our x-axis, the log base 10 of v. So here we have log base 10 of v, and then we add on the constant c, where c is the y-intercept. The y-intercept, that's minus 1.77. Okay. So here we have minus 1.77. Okay. And going from here to here is a bit complicated. And sometimes, well, let's think about this. On the left hand side, we have something involving a log base 10. On the right hand side, we have this thing which involves a log base 10 of 10. Sorry, just a log base 10. So if we were to combine these on the right hand side, somehow over here, we would also need another log base 10 of something, and then we can anti-log both sides to end up with this over here. And the key is over here to recognize that minus 1.77 is the same as 1.77 times by 1. So maybe if I write this in a different colour, hopefully you can recognise that. And 1, that's the same as log base 10 of 10. So here we have m log base 10 of v minus 1.77 times by log base 10 of 10. So hopefully you can see the link between those. And therefore, combining these logs, first of all, we can power slide this. So we have log base 10 of v to the power of m minus log base 10 of 10 to the power of 1.77. So when we come to combine these logs using the subtraction law of logs, we have log base 10 of v to the power of m over 10 to the power of 1.77. Okay? And therefore, anti-logging both sides, you can hopefully see d, that's equal to v to the power of m over 10 to the power of 1.77. In other words, d, that's equal to, well here, 1 over 10 to the power of 1.77, that's 0.0169, etc. And that's approximately the 0.017 given in the question. So therefore we can conclude that we have 0.017 v to the power of m. Okay? Well, here, actually, we have an n instead for our formula, with y equals mx plus c. So maybe correcting that right now will be quite useful. So here we have an n, because in the question we had an n given to us. Okay, so hopefully that's clear as to why we have an n instead of an m. Okay. So therefore, that's our final answer. Okay. Now for part B of the question, using the information given in figure 5 with k equaling 0.017, we have to find a complete equation for the model giving the value of n to 3 significant figures. And what we have over here given to us is this point 3020, and that's on the graph d against v. So let's use that. When d equals 20 and v is equal to 30, substituting these into this equation here, we have 20, that's d, that's equal to 0.017 times by v, which is 30, to the power of n. Okay? So we have over here 30 to the power of n, that's equal to 20 divided by 0.1, so that's divided by 0.017, we get a value of 1176.4, etc. So we have here n times by log base 10 of 30, that's equal to log base 10 of 1176.4, etc. And therefore we can find the value of n, that's equal to log base 10 of 1176.4, etc. divided by log base 10 of 30. And if we work this out, so we have log base 10 of this answer divided by log base 10 of 30, turns out we get 2.07, etc. So therefore, to 3 significant figures, d, that's equal to 0.017 times by v to the power of 2.08. Okay? And now for part C of the question. Sean is driving this car at 60 km per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. We have to use our formula to find out if Sean will be able to stop before reaching the puddle. And the first thing that should instantly pop into your head is the units are different. Here we have kilometers per hour, here we have something in meters, here we have something in seconds. So the first thing I would suggest you do is make sure that the units are the same. So for part C, we've got this 60 kilometers per hour, and we can convert this into meters per second by multiplying by 1000 and then dividing by 3600. So this is in meters per second. So working this out, we have 60 divided by 3600 times by 1000, that's equal to 16.6 recurring. So we have 16.6 recurring meters per second. Okay, so therefore he's driving his car at 16.6 meters per second. And what we know already is it takes him 0.8 seconds to react before applying the brakes. So we would have to use speed equals distance over time to find out the distance. So distance is equal to speed multiplied by time. So therefore, we can see that he travels the 16.6 recurring meters per second multiplied by the 0.8 seconds, it turns out we get 13.3 recurring meters. So what we also know in the question is that he notices a large puddle 100 meters ahead. So therefore we can find out how much distance he has to stop. So he has 100 minus this 13.3 recurring, which is 86.6 meters to stop. Okay, so knowing that, let's find out with our formula with V equaling 60 kilometers per hour. Now notice here we have to use that 60 kilometers per hour because that's the units of V. So we have over here D, which is equal to, when V is equal to 60, D, that's equal to 0.017 times by 60 to the power of 2.08. And if we work this out, so we have 0.017 times by 60 to the power of 2.08, it turns out we get 84.9 etc. meters. And therefore he stops in time. So therefore stops in time, because this value is less than this value. For question number 9, this discriminated well between candidates of all abilities. Let's have a look at what part A was. Part A, we had to show that we had a formula D equals k lots of V to the power of n, where k and n are constants and k is approximately 0.017. Many candidates wrote down a valid log equation as part of their explanation. Those who use mathematical reasoning to progress from log base 10 of D equals log base 10 of k plus n log base 10 of V to D equals kV to the power of n, or vice versa, usually showed an intermediate step in their working and were successful in their explanation. A few candidates made errors in progression between these two equations, and we see that over here. Those who made a direct comparison of their log equation with y equals mx plus c usually did so clearly enough, but sometimes did not allude to D equals kV to the power of n if using minus 1.77 rather than log base 10k in their log equation. A significant number of candidates did not apply the 10 to the minus 1.77 or use logarithms to show that k is equal to 0.017. Part B, where we had to find the value of n to 3 significant figures, people substituted in V equals 30 and D equals 20 into this equation, and then from there you can find n equal 20. A few candidates used the incorrect method of simplifying 20 equals 0.017 times 30 to the power of n to give this result over here. There was no need. Some candidates substituted in V and D the wrong way around, usually leading to n equaling 2.5, and a few used both V and D as 20. A minority substituted V equals 30 and D equals 20 into a correct log equation, while a few others correctly found n by finding the gradient between the known points shown here. The most common mistake was not writing a complete equation shown here or shown here after finding a correct n equaling 2.08. And the question did ask us to find a complete equation. Part C was a bit more difficult as well. We see a lot said over here for part C. A lot of candidates did apply that V equaling 60 into their exponential model, which is good, and then they found the break-in distance. Some then used the incorrect method of comparing this braking distance with the overall stopping distance. The majority attempted to calculate the thinking distance as either overall stopping distance. The majority attempted to calculate the thinking distance and either added it to their braking distance or subtracted it from 100. The main error was due to the units. Remember, the different units should be alarming to you. Some candidates did not attempt to convert the 60 kilometers per hour to meters per second. Other things that were said were that the candidates managed a partial conversion, with some using 1/75 meters instead of 13.3 meters as their thinking distance, and some of their candidates used an incorrect method of combining their values to give a dimensionally incorrect quantity. For example, they might add their braking distance to either speed or time. Candidates who obtained a thinking distance of 13.3 usually reached the correct answer and conclusion. If you compared the maximum speed to the stop at the puddle with the given 60, while even fewer compared the maximum value of n needed to stop the puddle with n equaling 2.08, and with correct conclusions that these with correct conclusions these were valid solutions. Question number 10. Figure 7 shows a sketch of the triangle AOB. The point C is such that OC is equal to 2OA. So let's add that in. We've got OA over here, so twice that. The point C will lie over here somewhere. So let's join those up. So here we have the point C, and the point M is the midpoint of AB. So the midpoint of AB, that's over here somewhere, and we've got this straight line which passes through C and the point M. So here we have the point M, and we've got a straight line passing through these 2 points, and this straight line cuts OB at the point N. So if we join these 2 points together, we end up with something looking like this. And here, where this straight line crosses OB, that's the point N. So we'll add this to the diagram here. We've got OA, which is equal to A. So if we add that to the diagram, we have here the vector A, and because OC is equal to twice OA, AC, that will equal the vector A. And we've also got the vector OB, which is equal to A. So this vector OB, that's equal to the vector B. Okay, perhaps if we write this over here, might make it a bit more clear. And in this question for part A, we have to find the vector CM in terms of A and B. So this is nothing more difficult than what you'd find at GCSE. We've got AB, that's equal to OB minus OA. So we've got the vector OB, that's B, minus the vector OA, that's A. The vector AM, that's equal to 1/2 of AB, the reason being M is the midpoint of AB. So AM, that's equal to 1/2 AB. So we have 1/2 lots of B minus A, which is equal to 1/2 B minus 1/2 A. And we've got CM, starting at C, finishing at M. Well, for CM, we can go C to A, and then A to M. And we've already worked out what AM is. C to A, that's minus A. So let's write all this down. The vector CM, that's equal to CA plus AM. So we have CA, which is equal to minus A, plus AM, which is 1/2 B minus 1/2 A. Working this out, we get minus 3/2 A plus 1/2 B. So that's the vector CM. Now for part B, we have to show that ON is equal to 2 minus 3/2 lambda, lots of A, plus 1/2 lambda B, where lambda is a scalar constant. So the first thing we need to recognize, CMN, that's a straight line. So let's write this down. CMN is a straight line. Okay. And because of that, we can conclude over here that Cn, that's equal to some constant multiplied by Cm. So we have lambda, lots of Cm, which is minus 3/2A plus 1/2 B. Okay. And the vector ON, starting at O, finishing at N, let's think about how we can get there. We can go O to C, and then from there we can go C to N. So the vector ON, that's equal to OC plus CN. OC, starting at O, finishing at C, that's twice A. So here we have 2A plus Cn, which we worked out here. So that's lambda lots of minus 3/2A plus 1/2 B. And therefore, if we tidy all this up, hopefully you can see ON, that's equal to, if we gather all the terms involving an A, we have 2 minus 3/2 lambda. So we have 2 minus 3/2 lambda A. And in terms of the B's, we have 1/2 lambda B. So we have 1/2 lambda B. Now for part C, we have to hence prove that ON to NB is equal to 2 to 1. So for this question, if ON to OB is equal to 2 to 1, then ON is equal to 2/3 OB, which is what we want to show in this question. So that's one way of tackling it. Now ON, if you compare that to what OB is, N lies on OB, so ONB is a straight line, and therefore ON, that's equal to some multiple lots of OB. We'll call that multiple T. So here we have ON equals T lots of OB for some scalar T. Okay. Now we already know what ON is. ON, that's equal to what we have over here. That's equal to 2 minus 3/2 lambda lots of A plus 1/2 lambda B. And that's equal to some multiple of OB lots of T. So we have T times by OB, OB, that's equal to B. And then we can now compare components to find out what lambda and T are. So now compare components, or now compare components. Hopefully what you can see, if we compare the A component, we have on the in terms of a's, we have 2 minus 3 over 2 lambda equals 0. In other words, lambda, that's equal to 4 over 3. And now if we compare the b component, comparing the b component, we have a half lambda equals t. So we have over here 1/2 lots of 4 over 3, that's equal to t. In other words, t, that's equal to 2/3. And therefore, what we can see over here is ON, that's equal to 2/3 OB, and therefore ON to OB, that's equal to the ratio 2:1. Question 10 was a vectors question. A lot of people found this question to be quite difficult. Part A, where we had to find CM in terms of A and B, this is simply a GCSE method. The most common approach was to see that CM is equal to CA plus AM. There were less efficient routes given, and you can read about those. Incorrect methods included applying CA equaling A instead of minus A, or applying AB equals A minus B instead of B minus A. In part B, that was quite demanding. A lot of candidates struggled to do this question. A minority of candidates deduced that Cn is equal to some constant lambda, lots of Cm, and applied this deduction to the root On equals OC plus Cn. Remember, you have to recognize that we had a straight line, and if you do that, it makes the question much easier. And you can read about the different methods used in the mark scheme. Part C, that was proved to be quite taxing for a lot of people. The crucial step was to recognize ON is parallel to OB, and hence it is a multiple of B with no A component. And we mentioned that over here, where we had that constant term being T. Only a few candidates then set A component ON to 0 to give the equation 2 minus 3 over 2 lambda equals 0. You can find lambda to be 4 over 3, and then from that you can find ON equals 2/3 B, and then from that you can state the ratio as we did over here. Question number 11. Figure 8 shows a sketch of the curve C with equation y equals x to the power of x, where x is greater than 0, and find, by firstly taking logarithms, the x-coordinate of the turning point of C. Solutions based entirely on graphical or numerical methods are not acceptable. This question is a bit difficult. We begin with part A, where we have y equals x to the power of x, and we were told to take logarithms. And if we take logarithms, we have to take logarithms of both sides. So we have the natural log of y equals the natural log of x to the power of x. We can power slide this to the front. So we have the natural log of y equals x times by the natural log of x. And now, remember the question said find the x-coordinate of the turning point. Turning point, when you see that word, you should be thinking to yourself, dy over dx equals 0. So, for us to differentiate this, we have something involving y's and x's. We'd have to use implicit differentiation. So, using implicit differentiation, well, if I differentiate the natural log of y with respect to x, using implicit differentiation, that would be 1 over y dy over dx. And for us to now differentiate x times by the natural log of x, we'd have to use the product rule. For the product rule, if we call this v, and we call, write it out nearly, if we call this v and this u, we have v times by u dash, so we have v, which is x, times by u dash, that would be 1 over x, and then we add on u, which is the natural log of x, times by v dash, that would be 1. And therefore, what we have over here is 1 over y multiplied by dy over dx, and that's equal to the natural log of x plus 1. And therefore, multiplying through by y, we have dy over dx, dy over dx, that's equal to y lots of the natural log of x plus 1. And we already know what y is. Y, that's equal to x to the power of x. So therefore, dy over dx, that's equal to x to the power of x times by the natural log of x plus 1. Okay? And for a turning point, dy over dx, that's equal to 0. So we have x to the power of x times by the natural log of x plus 1 equals 0. Now, x to the power of x cannot equal 0, because remember over here, x is greater than 0. And therefore, we can say that we have the natural log of x plus 1 equals 0. So, solving this equation, we have the natural log of x equals minus 1. X, that's equal to e to the minus 1. So the x coordinate of the turning point of C is e to the minus 1. So this over here is the x coordinate of the turning point of C. Okay, now for part B, the point P with coordinates alpha 2 lies on C, and we have to show that alpha is in between 1.5 and 1.6. Now, if we substitute in this coordinate into our equation for C, we have alpha to the power of alpha equals 2. So at the point alpha 2, substituting that into C, we see that we have alpha to the power of alpha equals 2. In other words, alpha to the power of alpha, that minus 2 equals 0, and therefore f of alpha, that's equal to alpha to the power of alpha minus 2. So remember, with an iteration question, we want to rearrange to get everything equal 0, and therefore state what f of alpha is in this case. And we're trying to show that we have a root in between 1.5 and 1.6. So when alpha equals 1.5, we have 1.5 to the power of 1.5 minus 2. So here we have 1.5 to the power of 1.5 minus 2. That's equal to minus 0.162, etc. And alpha equaling 1.6, we have 1.6 to the power of 1.6 minus 2, if we work this out. So working this out, we get 0.121, etc. And with that, we see that we have a change in sign, and we see that f of alpha is continuous, and therefore we have a root in between 1.5 and 1.6. Let's just quickly write that down. So we see over here we have a change of sign, and f of alpha is continuous, so we have a root in between between 1.5 and 1.6. And now for part C, using this a possible iteration formula that could be used to attempt to find alpha is x of n plus 1 equals 2 lots of xn to the power of 1 minus xn. Using this formula with x1 equaling 1.5, we have to find x4 to 3 decimal places. And it's only worth 2 marks, it's not difficult. We have xn plus 1 equals 2 xn to the power of 1 minus xn. We see that x1, that's equal to 1.5. x2, let's find what this is. So all we have to do, type in 1.5 into your calculator, and then we have 2 lots of answer to the power of 1 minus answer. x2, that's equal to 1.632, etc. x3, that's equal to 1.466, etc. And x4, that's equal to 1.673 to 3 decimal places. Okay. And now for part D of the question. Now for part D we have to describe the long-term behaviour of xn. So far up to x4 we've got this 1.673, and on our calculator that's still stored. So continuously pressing equals, let's see what happens. It turns out the values keep oscillating between 1 and 2. And that's what we've put over here. The values oscillate between x equals 1 and x equals 2, and therefore we have divergence. Question 11, this discriminated between candidates of all abilities. It was an implicit differentiation question for part A. We were advised to take logs, and once you take logs, you get log base y equals x log x. At this point, a significant number of candidates made no further credible progress. Some candidates used a complete method of applying the product rule to x ln x, and then implicit differentiation, as we did in the mark scheme, to get the final correct answer. Obviously turning point, that suggested dy over dx equaling 0. From that you can find x equals e to the minus 1, as we did in this question. Part B, well, before that, let's see what people did wrong. A few candidates used logarithms without reference to a base. Those who proceeded to obtain x equals 0.1 received partial credit, and those who obtained x equaling e to the minus 1 got full marks. A few candidates wrote y equals x to the x as y equaling e to the power of x ln x, and then applied dy over dx equaling 1 plus ln x lots of e to the power of x ln x equaling 0 to find the correct solution. Others differentiated both sides with respect to y and then found x equaling e to the minus 1. A few candidates applied the quotient rule but were very rarely successful in this method. Part B, most candidates evaluated their x to the power of x or x to the power of x minus 2 at both these points. A few candidates made any reference to the curve being continuous in this interval. Remember, for that change in sign method you have to talk about the curve being continuous, and if you do that you got the marks. And then for part C we had to find the value of x4. This was actually a quite easy question. Some wrote down the iterates x1, x2 and x3 as part of their solution. You had to state your answer to 3 decimal places. On part D, a lot of candidates gave correct descriptions such as the sequence oscillates between 1 and 2, or the sequence is periodic with period 2. Other descriptions such as alternates between 1 and 2 or kept getting 1 and 2 or fluctuates between 1 and 2 were condoned. Some credit was given for partial explanations such as sequence is non-convergent, sequence oscillates or series, or sequence is divergent. Give a full explanation if you can. Question number 12. We have to prove over here that cos of 3 theta over sine of theta plus sine of 3 theta over cos of theta is equivalent to 2 cot 2 theta, where theta doesn't equal 90 n degrees and n is an integer. So for these sorts of questions, we want to begin on one side of the identity and end up on the other side of the identity. So if we consider the left-hand side, considering the left-hand side of the identity, we have cos of 3 theta over sine of theta plus sine of 3 theta over cos of theta. And we can combine these fractions, so we have cos of 3 theta lots of cos of theta plus sine of 3 theta lots of sine of theta, and on the bottom we end up with sine theta cos theta. Okay, now hopefully over here you can recognize on the top and the bottom we have the angle formulae used. If you look over here, if we compare what we have here with what's given so far, we see over here that we have cos of 3 theta cos of theta plus sine of 3 theta sine of theta. And if we compare that with what we have over here, where we have a plus here, we use the minus in the formula, and can you see that A, that's equal to 3 theta, and can you see that B, that's equal to theta? So therefore on the top we have cos of 3 theta minus theta, and on the bottom, well, on the bottom hopefully you can recognize that hopefully on the bottom you can recognize we have our standard double angle formula, sine of 2 theta, well, let's put this in terms of A instead, sine of 2A, that's equal to 2 sine A cos A, and therefore sine A cos A, that's equal to 1/2 sine 2A. So hopefully you can see that sine theta cos theta, that's 1/2 sine 2 theta. So on the bottom we have 1/2 sine 2 theta. So on the top we have cos 2 theta, on the bottom we have 1/2 sine 2 theta, and therefore we have 2 cos 2 theta over sine 2 theta. Cos 2 theta over sine 2 theta, that's cot 2 theta, so we end up with 2 cot 2 theta, and therefore since the left hand side is equivalent to the right hand side, we have shown the identity to be true. Now for part B of the question, hence solve for theta being in between 90 degrees and 180 degrees, this equation equaling 4, giving any solutions to one decimal place. So we can use what we had in part A. We can replace this bit with 2 cot 2 theta. So we have 2 cot 2 theta equals 4. Cot 2 theta, that's equal to 2, and therefore we have cot 2 theta, that's the same as 1 over tan 2 theta, that's equal to 2, and therefore tan 2 theta, that's equal to 1/2. Okay, so first thing we can do, we wish to solve this in the range 90 to 180. So if we change the range, if we change the domain to 2 theta, we have 180, which is less than 2 theta, which is less than 360. So what we have over here then is, if we solve this equation, so first thing we need to do is change the angle unit to degrees. We have 2 theta, that's equal to the inverse tan of 1/2. We need to add on 180 to get this in the required range. So we have 206.6, okay? So we have 206.56, etc. Let's add on another 180. That's above our required new range. So therefore, theta, that's half of this. So we have theta, which is equal to 103.3 degrees to 1 decimal place. Question 12, part A, that was a standard proving an identity. Many struggle to apply a complete strategy which would help them make significant progress. There were various different answers in their immediate stage of working, from which you can find the correct result of 2 cot theta. A lot of people used way 1 in the mark scheme, which is what I did, to obtain this result over here. And many saw that sine theta cos theta equals 1/2 sine 2 theta in the denominator. On the top, we've got cos of 3 theta minus theta, which cancels out, and from there you can simplify. The common error over here was to give cos squared 3 theta plus sine squared 3 theta over sine theta cos theta, or sine 4 theta plus cos 4 theta over sine theta cos theta. Way 2 in the mark scheme was the most popular approach. The way 2 describes in the mark scheme was to combine the fractions by rationalizing the denominator, and you can read all about that over here and take a look at the mark scheme. Some people weirdly spend a lot of time writing out cos 3 theta and sine 3 theta in terms of powers of sine, which wasn't needed. Part B of the question, that was solving one of the trig equations. A lot of people used their part A to get tan 2 theta equaling 1/2. A lot of people gave theta equaling 103.3, which is the final answer. Common errors included attempting to solve tan 2 theta equals 2 and finding more than one value for theta. Remember, you have to look at the range for this question, the domain for this question. There were a few candidates who applied this equation equaling to 4 and they found a quadratic and solved that. Question number 13. A manufacturer produces a storage tank. The tank is modelled in the shape of a hollow circular cylinder enclosed at one end with a hemispherical shell at the other end, as shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has radius r meters and height h meters, and the hemisphere has radius r meters. The volume of the tank is 6 meters cubed, and show that according to the model, the surface area of the tank in meters squared is given by 12 over r plus 5 over 3 pi r squared. And we're told that the sphere of radius r has volume 4/3 pi r cubed and surface area 4 pi r squared. So first thing, we know already from the question the volume that's given by 6 meters cubed. So for part A, V equals 6, that's what we know already. We have the cylinder bit, which is pi r squared times by h, that's what the volume is of the cylinder bit. So we have pi r squared h, and then we add on the hemisphere at the top. And the hemisphere, that's half sphere, so the volume is half of this 4/3 pi r cubed, which is, well, we'll write it out in full. So we add on 1/2 lots of 4/3 pi r cubed. And we know that this is equal to 6. And if we tidy this up a bit, we have pi r squared h plus 2/3 pi r cubed. This is equal to 6. And the idea is over here, if we find an expression for the surface area, we can use what we have over here to simplify the problem. We first of all need to find out what h is. So doing that, we have pi r squared h equals 6 minus 2/3 pi r cubed. So h, that's equal to 6 over pi r squared, okay, minus 2 pi r cubed over 3 pi r squared, okay. And therefore we can conclude here h, that's equal to 6 over pi r squared minus 2r over 3. Okay. Now the surface area of this tank, that's given by pi r squared, so that's the circle at the bottom, plus 2 pi r h, that's the outer edge of the cylinder, and then we have a half lots of 4 pi r squared, and that's the hemisphere at the top. So the surface area, that's given by pi r squared, that's the circle at the bottom. We've got the bit for the cylinder, 2 pi r h, and then we add on 1/2 lots of 4 pi r squared. So the surface area, that's given by pi r squared plus 2 pi r h plus 2 pi r squared, and I think at this point we can actually combine these together. So here we have 3 pi r squared plus 2 pi r h. Okay. Now, if we call, well, let's conclude over here that the surface area is given by this. If I call this equation 1 and this equation 2, substituting in equation 1 into 2, so substituting equation 1 into 2, the surface area, that's given by 3 pi r squared plus 2 pi r h. H we already know, that's 6 over pi r squared minus 2/3 r. So we have 2r over 3. Okay. So we can tidy this up a bit. The surface area, that's equal to 3 pi r squared plus, now if we expand and simplify this, here we have 12 pi r over pi r squared, and then here we have minus 4 pi r squared over 3. So we can therefore tidy all this up. we have the surface area, which is given by, well, here we have 12 over r, and then here 3 pi r squared minus 4/3 pi r squared, that's 5 over 3 pi r squared. So we add on 5 pi r squared over 3. Okay, so that's what we wanted to show. Let's actually move this over here. Now for part B of the question, the manufacturer needs to minimize the surface area of the tank, and we have to use calculus to find the radius of the tank for which the surface area is a minimum. So what we have over here is a typical optimization question. So we have a minimum surface area when dSA over dr is equal to 0. Okay, so we need to differentiate this. So first of all, dSA over dr, that's equal to minus 12 over r squared plus 10 pi r over 3. Okay, remember pi is just a number. So in other words, we have minus 12 over r squared plus 10 pi r over 3, that's equal to 0. And if we multiply through by r squared, we have minus 12 plus 10 pi r cubed over 3. That's equal to 0. Okay, tidying this up a bit more, we want to find out what r is, don't we? So if we tidy this up a bit more, we have 10 pi r cubed over 3. Actually, we can skip a step. We have pi r cubed over 3, and that's equal to 18 over 5, and therefore r, that's equal to the cube root of that's cube root 18 over 5 pi. Okay, so that is our final answer. So if we work this out, we see that r is equal to the cube root of 18 over 5 pi, which is 1.05. Okay, 1.05 to 3 significant figures. Okay, so now for part C, we have to calculate the minimum surface area of the tank, giving the answer to the nearest integer. So the minimum radius, that's 1.05, etc. And all we have to do is substitute in to this over here. So therefore the minimum surface area, that's equal to 12 over 1.05, etc. plus 5 pi lots of 1.05, etc. squared over 3. So if we work this out, we have 12 over this plus 5 pi over 3 lots of this squared. So we end up with 17.20, etc., which is 17 to the, so we have 17 meters squared rather, to the nearest integer. Okay. So hopefully that makes sense. Question 13, this was actually quite a hard question. Let's see what's said in this question. For part A, successful candidates followed a correct strategy of forming an equation for the volume, rearranging the equation for H in terms of R, and then substituting that into the surface area. That's exactly what we did. Some candidates did not have the sphere formula. Remember, we've got a hemisphere. Other candidates did not include the area of the circular base for their surface area. That gave an incorrect expression. And there were other errors stated as well, but you just had to recognize what you needed for the shape. Part B, where we had to find the minimum radius, there were those who found their value of R by setting dA over dR equaling to 0. They found the correct R from that. Some gave an exact answer, which was condoned. Some differentiated A incorrectly, and they got logs from that somehow, I don't know how. But there were a couple who found the value of R by finding the second derivative, which was incorrect. Part C, we just had to substitute our R back in to our A. A lot of people did that and they found the minimum surface area to be 17. A few candidates who made no credible progress substituted their value of R found from solving the second derivative equal to 0 for A. Remember, for a minimum we have to find the first derivative. We can verify whether something is a minimum or maximum by finding the second derivative, but there was no need for that. Question number 14, we have to use the substitution for part A, u equals 4 minus square root of h, to show that the integral of dh over 4 minus square root of h is equal to minus 8 times by the natural log of 4 minus square root h minus 2 times square root h plus k, where k is a constant. Okay, so for part A, we begin with u equals 4 minus square root h, which is equivalent to 4 minus h to the power of minus 1/2. Okay, and from here we can state that the square root of h, that's equal to 4 minus u, and therefore du over dh, that's equal to minus 1/2 lots of h to the minus 1/2, which is the same as minus 1 over 2 root h. And therefore dh, that's equal to minus 2 times by the square root of h times by du. We know what the square root of h is. That's equal to 4 minus u. So we have minus 2 lots of 4 minus u du. Okay, and having said all that, we can replace as necessary with our integral. We have dh over 4 minus square root of h. That's going to be equivalent to, well, here we have 1 over u, and that's because u is equal to 4 minus square root h. So we have 1 over u lots of dh is minus 2 lots of 4 minus u, and we're integrating this with respect to u, and all this is equivalent to minus 2 lots of, here we have 4 over u minus 1. Okay, so we have 4 over u minus 1 du. And if we work this out, we get minus 2 lots of 4 times by the natural log of u minus u plus c. Okay, and we need to continue simplifying all this. So here we know what u is, that's equal to 4 minus square root h. So we have minus 2 lots of 4 times by the natural log of 4 minus square root h minus 4 minus square root h plus c. So here we have minus 2 lots of 4 times by the natural log of 4 minus square root h minus 4 plus square root h plus c. And if we expand this minus 2 into the bracket, we have minus 8 times by the natural log of 4 minus square root h plus 8, because minus 2 times by minus 4, that's plus 8, minus 2 times by the square root of h, and then we have the plus c. And if we tidy all this up, we have minus 8 times by the natural log of 4 minus square root h minus 2 times by the square root of h, and then 8 plus c, that's going to be a constant k. Okay, so the 8 plus the c gives the plus k. Okay, and that's what we wanted to show. Part B of the question, a team of scientists is studying a species of slow-growing tree. The rate of change in height of a tree in this species is modelled by the differential equation dh over dt equals t to the 0.25 lots of 4 minus square root h over 20, where h is the height in meters and t is the time measured in years after the tree is planted. And we have to find, according to the model, the range in height of trees in the species. Okay. So what we have over here is the maximum height. That's when the tree stops growing. Okay. So in other words, when the tree stops growing, the max height is when dh over dt, that's equal to 0. Okay, so we already know what dh over dt is, that's given here, and we set that equal to 0. So we have t to the 0.25 lots of 4 minus square root h over 20, and this is all equal to 0. So we have 4 minus square root h, that's equal to 0, and therefore h, that's equal to 16 meters, and therefore the range of values, we have 0, which is less than or equal to h, which is less than or equal to 16. Now for part C, one of these trees is 1 meter high when it's first planted, and according to the model, we have to calculate the time this tree would take to reach a height of 12 meters, giving an answer to 3 significant figures. So what we have to do over here is solve this differential equation. So for part C, solving this differential equation, let's begin by writing out the differential equation dh over dt, that's equal to t to the 0.25 lots of 4 minus square root h over 20. And what we want to do over here, when we come to separate the variables, remember, if you look at what we have in part A of the question, we have the integral of dh over 4 minus square root h, and if we somehow separate the variables in terms of t and h, on the h side, if we get this, we can use our answer to what we had in part A. So let's do that. If we separate the variables, we have 20 lots of 1 over the 4 minus square root h dh, that's equal to t to the 0.25 dt, and obviously we'll have to integrate both sides. So integrating, well, here we have already worked out what that is. Let's just move this here. We've already worked out what that is. So we have 20 lots of minus 8 times by the natural log of the mod of 4 minus square root h minus 2 times by the square root of h. That's equal to, well, if I integrate this, we have 40 to the 5 over 4 over 5 plus some constant a. Okay? Now, of course, you may notice that before we had a plus k, and all I've done over here is sort of taken that k over to the side, because either way, when you're going to integrate constants, when you integrate, you're going to get some constants, and I've just taken all those constants over to one side to get a massive constant a. Now, we know that initially the tree has a height of 1 meters when it's first planted. So when t equals 0, we see that h, that's equal to 1. So we have 20 lots of minus 8 times by the natural log of 4 minus square root 1 minus 2 times by square root 1, that's equal to 0 plus a. In other words, a, that's equal to minus 160 times by the natural log of 3 minus 40. And therefore, we can conclude our particular solution to this differential equation. We have minus 160 times by the natural log of the mod of 4 minus square root h minus 40 times by square root of h. This is equal to 40 to the 5 over 4 divided by 5 minus 160 times by the natural log of 3 minus 40. And we're looking at the time it will take for us to reach a height of 12 meters. So we're seeing what will happen when h is equal to 12. So when h is equal to 12, we have minus 160 times by the natural log of the mod of 4 minus square root 12 minus 40 times by square root 12. This of course is equal to 40 to the 5 over 4 over 5 minus 160 times by the natural log of 3 minus 40. So what we can see over here is that 40 to the 5 over 4 over 5, let's work this out. So on your calculator, type all this in on the left hand side. So we have minus 160 times by the natural log of the mod of 4 minus root 12 minus 40 root 12. So we get minus 38 point something, and then we add on the 160 times by the natural log of 3 plus the 40. It turns out we get 177.02 etc. So we have 177.02 etc. And therefore t to the 5 over 4, that's equal to this result multiplied by 5 and then divide by 4. So that's 221.27, etc. And therefore for us to find t that's equal to 221.27, etc. to the power of 5 over 4. So we raise this to the power of, raise this to the power of 4 over 5. So we have this to the power of 4 over 5. So therefore, t, that's equal to 75.2 years to 3 significant figures. Okay, so if we go back to the question, yeah, so we have to give our answer to 3 significant figures as shown over here. Question 14, this was a differential equation question. Part A, where we had to use our substitution to find an integral. A lot of people did this correctly, but there were some who incorrectly differentiated to give du over dh equaling a half h to the minus a half. At this stage, a lot of people failed to make further progress. Many candidates struggle to apply the substitution completely to give the integral in the form k lots of 4 minus u over u du, with some making sign errors in the numerator. Those who progressed this far generally went on to divide each term by the numerator u to give a correct integral in the form a over u plus b with respect to u. Either way, once you integrate correctly, you can substitute back into your solution to find out the integral in terms of h. There were a large number of candidates who incorrectly stated that k equals 8. Remember, we had a couple of constants which when we combine them gives the k. So we had this constant c plus the constant 8 gives the constant k. Some people use integration by parts on this integral over here, and then from that they didn't progress far. Part B, many candidates correctly set dh over dt equaling 0, and they deduced that h is equal to 16, and then they had to give a range of values. Some candidates mistakenly thought the square root of h equaling 4 gives h equals 2. I don't know why you do that. For part C of the question, let's see what was said over here. We had to solve our differential equation. Many candidates who attempted part C separated variables correctly. Some candidates integrated t to the 0.25 incorrectly, while others integrated 1 over 4 minus square root h without reference to the result from part A. Some people did not find the boundary conditions correctly. Most candidates who progressed this far to use these boundary conditions applied a complete process of substituting their constant of integration and h equals 7 to their integrated equation and solving this equation to find their value of t. In many cases there were some sign errors. Finally, when we had this bit over here, solving for t wasn't that hard, but some people did not realize that how to solve this equation, which was actually quite disappointing.